All right, today we're going to be factoring this polynomial expression here. And this is probably the most difficult one I've done on the channel to date. Normally, we're used to factoring an expression in order to find the roots. But for this one, actually the best method is going to be to work the other way. We're actually going to find a root first to pull out a factor. And that'll give us our first factor, which will allow us to tackle a simpler polynomial. So we want to pull out one factor first, and there's this concept called the rational roots test, where every zero, right, for an expression with a leading coefficient, which is an integer, can be expressed as p over q, where p is a factor of the constant, or in this case, our d value. So p is going to be factors of 12. So we can actually just list those all, 12 and 1, 6 and 2, 3 and 4. Okay, so these are all of the p-values that are available to us. And then q is going to be the leading coefficient, the factors of the leading coefficient, all right? So it's going to be 3 and 1 are our only factors there. So let's list all of our possible values of pq real quick. We have 12 over 3. We have 1 over 3. We have 6 over 3. 2 over 3. 4 over 3. 12 over 1. I missed 3 over 3. 12 over 1. 1 over 1, 6 over 1, 2 over 1, 3 over 1, and 4 over 1. So quite a few, but some of them repeat. And what I can see here is that we have 1 over 1 as one of our options. And that's usually going to be the simplest one just to check. So let's plug in 1 to this expression and see if it zeroes out, just to test if 1 actually is a root. Because it's probably the fastest one to test. So 3 times 1 to the third plus 10 times 1 squared, right? Minus 1 minus 12. So we have 3 plus 10 minus 1 minus 12. And we can see that 13 minus 13 equals 0. So 1 is a root. So x equals 1 is one of our solutions. If this equation were set to 0, right, x equals 1 would be a solution. And that lets us know that we actually can tell one of our factors. We know now that x minus 1 is going to be a factor for this expression. And the reason for that is because you can zero out x minus 1 by plugging in 1. So it's one of our factors. And now we can actually pull x minus 1 out of this equation. All right, I wanted to get a second sheet of paper involved so we don't crowd our main workspace. But basically where we left off, we're trying to divide our original expression by our now known factor, which is x minus 1. So we can do that just by setting up a long division problem. X minus 1 here. 3x to the third plus 10x squared minus x minus 12 inside of our long division. I'm going to switch markers. And yeah, the way you divide polynomial expressions is you just divide the leading coefficient first. So x goes into 3x cubed how many times? 3x squared, right? Because x times 3x squared equals 3x cubed. And yeah, then you just multiply x times 3x squared equals 3x cubed. Negative 1 times 3x squared is negative 3x squared. And then you subtract. So 3x cubed minus 3x squared is 0, good. Negative 3x squared minus 10x squared is 13x squared, right? The double negative. So we have 13x squared is our new number that we want to divide x by. X goes into 13x squared, 13x times x times 13x is 13 x squared, negative 1 times 13x is minus 13x. 13x squared minus 13x is 0. Negative x rather, minus 13x is positive 12x. X divided by 12x is 12. X times 12 is 12x. Negative 1 times 12 is negative 12. Minus positive 12x minus 12x is 0. Negative 12x minus negative 12x is also 0. So we have no remainder. This is our final divided form. So let's copy that now onto our original page. 3x squared plus 13x plus 12. And I'll get rid of this extra division page. All right, and now we're in the home stretch of this problem. It's going to be a simple AC method from here on out, and then a factor by grouping. So A and C, we've got 3 times 12. 3 times 12. Somehow I keep picking up the bad pen. I don't know why I keep around a bad pen. 3 times 12 is 36. And so that means that we need numbers that multiply to 36 and add to 13. Let's run through some factors. 36 and 1. We've got 18 and 2. We've got 12 and 3. We've got 9 and 4. And we can stop there. 9 and 4 add to 13. So now we can rewrite an equivalent expression below here. So we'll make this into something like 3x squared plus 9x plus 4x plus 12. And now you should see something very encouraging. Our A and our B value have a ratio of 3 to 9. And our C and our D value have a ratio of 4 to 12. And these are, of course, equivalent at 1/3, which means that we can solve by grouping. So let's make our groups. I'll just add the groups here, like that. And now let's pull out the biggest factor that we can from each of these two groups. The biggest factor that comes out of 3x squared plus 9x is going to definitely be 3x, leaving behind 3x plus 3. And the biggest factor that can come out of 4x squared plus 12, sorry, it leaves behind x plus 3. The biggest factor that can come out of 4x plus 12 is going to be 4. So plus 4 times x plus 3. Now you see both of our brackets now contain x plus 3, which is a great sign. So now we just have to rewrite this in a factored form. So both of our x plus 3 terms are multiplied by different things, so we can write those two things together as 3x plus 4, and put that in brackets next to x plus 3, the things that they're multiplied by. And now we can't forget our other factor that we worked so hard to find above here, this x minus 1. So we'll bring that down. And our final factored form, glorious, x minus 1 times 3x plus 4 times x plus 3. Hey guys, if this video helped you out at all with your math homework, I'd really appreciate it if you like and subscribe especially, so that I can continue making more videos like this one. Thanks.